Hello everyone. So in this tutorial, we are gonna see what is the difference between data types, float and double. So let's start. So what we have seen till now is float occupies a memory of 4 bytes, while double occupies how much? 8 bytes, right? A basic difference we have seen till now is this. I want to know now what range of values can be fit into float and double. Okay, so how do we know that? So I would introduce you a library or a functionality that C++ gives me, numeric limits. Fine. Now, if I mention that, okay, numeric limits of float, okay, corresponding to this, I can access what is its lowest value it can store as well as what is the largest value it can store. How? Let me show you that. After two double colon marks, I can say lowest. Okay. And if I try printing this will fetch me what is the lowest value my float data type can hold. Let us try that. Fine. So if I try running this, you can see what's the lowest value that's coming up. Okay. Let us write it somewhere. It's coming out to be minus 3.4 into 10 to the power 38. Right? A lowest value that float can hold. Fine. Okay. How about max? How should we find it? Okay. So let me copy this. Let's see what function can access the max value. So instead of lowest, I just need to write max. Let me try running this. Okay, now we have two values. First one is the minimum and second one is the maximum. What is the maximum? We have got it's positive of 3.4 into 10 to the power 38, right? What is it? 3.4 into 10 to the power 38. Correct. This is the range in which float values can lie. Now let's similarly move on to the double part. What range of value it can hold? Okay, so I've written the range of float in the corner and now I am to do the same thing for double. Okay, let us calculate. Fine. So see, the last two values correspond to that of double. First one is giving me the lowest value and the last one is giving me that of the maximum value. So how much double? From where to where my double can lie? So double can hold a minimum from the minimum of 1.8 into 10 to the power 308. Okay, 10 times greater to 1.8 into 10 to the power 308. It's positive value. Okay, so we can see that the range of double is really long as compared to float. Okay, now another difference. Let's move on to that. I hope you are clear with this. So I'm wiping this out and let's see another difference. Okay, now something there is called precision. Okay, what is precision? So first, let us have a few dry runs. Let's suppose I have a float variable. Okay, F. That is initially storing 3535 2.353535, okay, or 33, let's say. If I try to print this, what result will be coming out? Let's see that. Okay, you can see my original number was 353533, but it is showing till 5 decimal points only. Okay, the output is showing till 5 decimal points. So whatever we have, my compiler is designed in such a manner that by default 5 decimal points only will be shown, right? Not more than that by default. If I have suppose some other kind of values, suppose that this is 39, let's say the last digit is 9, then what will happen? So let me try running this again. You can see that, okay, since I am bounded by a default value of 5 decimal points, what will happen? From the fifth number, whatever content I have, that will get rounded off. So since 39 is closest to 4, the fifth digit that I have got here, that has been rounded off to 4. Since by default I can see up to 5 decimal points only. So if necessary, rounding off will take place, right? Let's move on. Now see, if I say that I don't want to see, okay, till fifth decimal point, I have a priority that give me a result till 2 decimal points only. Okay, so what I will say, set precision. This is the function that I have, and using this, if I specify 3 and then I try to print the value of f, what happens? Let us see that. Okay, you can see once I've mentioned this 3 inside set precision, what result is coming up? Result is coming out to be 2.35. Okay, now let us try to figure out how is it happening. So suppose that this is a number 2.35359, right? Oh, sorry, 39. If I mention set precision of 3 for f, what will happen? Just before 3, just before the third digit after the decimal point, just before the third digit, that is from the second digit onwards, whatever data we have, that will be getting rounded off. Since 53 is there, okay, the entire thing has been rounded off to 5 only. And then what I'm able to see, 2.35 as a result. Entire content from the second digit itself, one less than what value I have given inside the set precision mark. Okay, a value, a digit, one less than that. From there, whatever is the content, that will be getting rounded off, and I will be getting the final result on my screen. That's how set precision works. Fine. Now let us have a bigger value. Okay, for float, let's have a bigger value. If I say that float now will be storing 10 decimal points, okay, up to 10 decimal points. Let's say 45656, and I want that from the ninth digit onwards, everything should be rounded off. So let me mention 10 here then. Fine, done that. And let me try running my program. See, is my result coming good? What was my original number? 2.3535395656, right? What result I have got? 3535 came good. Okay, both of the 35 and 35 came good. 39 came good, right? Now what had happened after that? It has given me 467. From the seventh digit onwards, everything started coming wrong, right? This entire thing, okay, sorry, I think 5 was initially there. Okay, yeah, somehow I mistook it. What had happened? This 5656 has been now replaced with 467, not at all matching with how it should have been rounded off, right? So what we can say, from the sixth, after the sixth digit onwards, after the sixth digit of decimal point onwards, float is not storing the data correctly once I'm trying to round it off. Okay, this is not possible. So what we say is that float has a precision till 7 decimal points after the decimal dot. Until 7th decimal point, it can hold correctly. Okay, till this point. Okay, till this point, it can hold data correctly. Okay, once you try to store, once you have in your number more than 10 digits after the decimal dot, that anomaly will start. The anomaly will start because float cannot store a bigger range of decimal values or a bigger range of digits after the decimal point. Okay. Now let me try the same thing with double. Okay, let me try the same thing with double. What happens? I will just change the name from float to double. Okay, now let's see whether the double variable is able to give me correct result or not. Okay, let me try running this. Okay, let us see whether the result is coming good or bad. Fine. So what had happened? What's my result? 2.353539.566. Right? This is correct, this is correct, this is correct, this is correct, right? And from the ninth slot onwards, 5, 6 has been rounded off to 6. So we can say that if we are trying to store, if we want a precision till 10th digit point, or if we want to round off everything from the ninth decimal point, and we store the entire value inside a double variable, okay, that's the entire rounding off is coming good, or the data is getting stored correctly. That's what we can see here. Fine. So see, double has a precision of 15 decimal values. Double has a precision till 15 decimal digits. That means after the decimal dot, it can hold data correctly until 15 decimal points. Unlike float, that was only limited to 7 decimal points. So again, after the decimal points, if you want to store more data, double is preferable. I hope this point is clear to all of you. If you have any doubts, you can put the entire thing into comments. Now some more points I would like to discuss. That okay, whatever variables we have till now, this double f, okay, they are the variables. This f is a variable. Suppose that int a. These things are variables. F, a, all are variables. Whatever values they store. Let's say f is storing 2.333, okay, and a is storing 1 or 2 or 3, let's say. These values are called literals. Okay. Whatever values we store, let it be a character, let it be a string, they are called literals. Fine. Okay, so I hope you liked this video. If you liked, please like, share, subscribe. Thanks for your time.